Hello and welcome to another Mr. Marriott's Maths video. This time we're going to attempt question 6 from the Leeds Maths School Further Statistics 1 Assessment number 7. George throws a ball at a target 25 times. Each time George throws a ball, the probability of the ball hitting the target is 0.52. The random variable x represents the number of times George hits the target in 25 throws. And part A is asking us to find two probabilities. But first of all, let's write down the distribution. X is distributed binomial 25, 0.52. Because we're doing 25 trials of throwing the ball. Each throw has a probability of success of 0.52. So part I, the probability that x is equal to 12 is equal to 0.1460 to 4 decimal places. Part 2. The probability that x is greater than or equal to 7 is equal to 0.9959 to 4 decimal places. Part B. George now throws a ball at the target 350 times. Use a normal approximation to calculate the probability that he will hit the target more than 210 times. So our mean is equal to NP. And actually we need to write down our distribution. We don't need to write down our distribution, we can use N and P from the question. So N is 350, P is 0.52. So our mean mu is 182. Our variance sigma squared is equal to NP1 subtract P, which is equal to 350 multiplied by 0.52 multiplied by 0.48, which is equal to 87.36. So now we can write our distribution, and I'm going to use the letter y. Y is approximately distributed normally with mean 182 and variance 87.36. Some people might like to write y is distributed approximately normally 182 and the square root of 87.36 squared, just to identify that the square root of 87.36 is the standard deviation. So we want the probability if x was our distribution binomial 350, 0.52, I want the probability that x is greater than, more than 210. So I need to perform a continuity correction. So I'm going to imagine that I've got a bar that's centred at 210. And I'm told that I'm going to be above this bar. So I want to be to the right hand side of this bar. And I don't want to include the value 210. So I'm going to be starting at the top end of this bar. So what value am I going to start at for my continuous distribution? I'm going to start at a value 210.5, the top end of the bar centred at 210. So this is going to become the probability that y is greater than or equal to 210.5. We don't need the inclusive inequality, it can be a strict inequality, because the normal distribution doesn't have any probability at exact values. Either one is fine, and the probability that y is greater than or equal to 210.5 is equal to 0.00115 to 3 significant figures. And that's the answer to this question. So where do all of the marks come from? Well, there's a method mark for writing down the distribution of x in A, and an accuracy mark for each probability. This method mark can be implied by the probability 0.1460. For part B, there is an independent accuracy mark for the approximate distribution. There's a method mark for performing the correct continuity correction, and an accuracy mark for giving the correct probability. And that marks the end of this question. So thank you for watching, and until next time, goodbye.